All right, here we go with section 9.8. We're talking about the roots of a quadratic equation. So we've talked about roots before when we did our quadratics, and that is defined as values of x so that your quadratic equation will equal to 0. So essentially, we're talking about x-intercepts, right? So roots and x-intercepts and zeros, they all are the same thing. And so if anybody talks about a 0 or an x-intercept or a root, you'll know what they're talking about. So if we go back and we look at our parabola, there were 3 different options about how our parabola could be placed on the coordinate plane. The first way is if your parabola actually sits on the x-axis, which we looked at in our investigation when we started the unit. What that means is that your parabola only intersects the x-axis exactly once, and it's at that point of the vertex. So because it's only intersecting the x-axis once, that means that there is only one real root. And you can solve for it very easily. Okay, next option is, say your parabola is shifted down a little bit. You will end up seeing that it intersects the x-axis twice. And so that means you get 2 real roots. They may be rational or irrational. That doesn't matter. It's the fact that they are real numbers. So you can definitely see that your parabola intersects it twice. The third option is, what if your parabola was shifted in such a way that it never intersects your x-axis? In that case, you have 0 real roots, but you can still solve your quadratic equation using the quadratic formula or completing the square, but you're going to end up getting 2 imaginary roots. So that means that when you go through and you solve it, you end up getting a negative underneath the radical sign. And now that we have imaginary numbers and complex numbers that we can work with, we can actually say that the roots are imaginary and figure out what they are. It just means that the parabola does not intersect the x-axis. Okay, so if you want, keep this visual in mind. But what we're going to do is we're going to take a look at the discriminant of your quadratic formula. So the discriminant is simply the part or the expression that is underneath the radical sign, so the b squared minus 4ac. Because that number, when you solve for it, is essentially telling you the nature of your roots and how many you're going to have. Are they going to be real? Are they going to be imaginary? Are they rational? Are they irrational? Do you have 1 or 2? And that specific number, when you calculate that number out, tells you a lot about what your roots are going to look like. Not necessarily what they are, but just what they're going to look like. So first of all, if b squared minus 4ac is equal to 0, that means that there's going to be 1 real root. So if you think about it, this whole quantity is 0. There's nothing to add or subtract. You just get negative b over 2a, which is the x-coordinate of your vertex. So 1 real root. If b squared minus 4ac is positive, so greater than 0, so if this number is positive, that means you get 2 real roots. You have a real number. You can take the square root of a positive number. The thing is, sometimes it's going to be a perfect square, sometimes it's not. So sometimes you get rational roots, sometimes you get irrational roots, but they're still real. And then if b squared minus 4ac is less than 0, there's going to be 0 real roots. But instead, you get 2 distinct, meaning different, imaginary roots. And what you're also going to know is that they are complex conjugates of each other. Okay? So we're going to do a lot of testing to see what kind of roots we end up getting just using our discriminant. So here's an example. They're asking us to determine the nature of the roots, not what they actually are. So we're going to go through and plug in the numbers to the discriminant, b squared minus 4ac. Remember to take all the appropriate signs with you when you plug them in. And you simplify, and we get 196. So right away you're saying, oh, it's positive. I'm going to get real roots. You can tell that you're going to get 2 real roots because it's not 0. But even more so than that, since 196 is a perfect square, we're going to get two real rational roots. So you do have to put in that rational versus irrational if you're getting two real roots. So don't forget about that. All right, what else could we do with this? Well, what if they ask us to figure out a specific value for one of our parameters, a, b, or c, that's going to produce a certain type of root? So in this case, we're looking for k, which is in the a position, and it says what k will give you imaginary roots instead of real roots. So what we're going to do is set up an inequality, because we want the imaginary roots, it's going to be less than 0, for our discriminant. And we're going to plug in all the numbers except a is going to be k. So we plug that in, so we have the b squared minus 4k times c, which is 5. And then we want this to be imaginary, so we're going to say that that whole value has to be less than 0. So then we go through and we simplify this, and we end up getting k is greater than 5. So any k that you choose that's larger than 5 is going to give you imaginary roots instead of real roots. And that's your solution. So you will sometimes have to deal with these inequalities that you're going to be working with. Okay, hopefully this will be a very simple section for you guys. All right, let's see. Later.